Did you know that the first infrared carbon dioxide sensor was invented in 1943? It's true. Non dispersive infrared or NDIR technology, which is pretty common these days for CO2 detectors, didn't come around until 1993. Today, indoor carbon dioxide sensing is more important than ever before. Why is that? Well, we are spending more time indoors, and our buildings are more energy efficient than ever before, which does cause less airflow from outside. We also now know that increased CO2 levels have been found to cause a whole slew of health problems. So, what can we do about sensing CO2 in indoor spaces? We should talk to Sensirion about that. They've got some ideas. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Dr. Kaitlin Howell from Sensirion and I explore the correlation between ventilation and carbon dioxide sensing, and how the features of Sensirion's STCC4 CO2 sensor can enable air condition monitoring with ease. Hi, Kaitlin. Thank you so much for joining me.
Hi, Amelia. Thanks for having me.
Absolutely. Okay, so we're chatting all about the STCC4 CO2 sensor today, which can enable healthy air in every home. So, first, Caitlin, why is there a need for better solutions for indoor air quality these days?
Well, Amelia, the reality is that we spend most of our time indoors, whether at home or in the office or in commercial spaces like the gym or the grocery store. And unfortunately, indoor air pollution can be significantly higher compared to outdoor levels due to sources like gas stoves and fireplaces, more energy efficient buildings, so they're more airtight, and as well as insufficient ventilation of these indoor spaces. For instance, a study found that only 22% of surveyed homes had a continuous mechanical ventilation system with sufficient ventilation rates to meet the US standard for residential ventilation, which is ASHRA 62.2. And other studies have similarly shown that in many homes today, the installed ventilation systems are either not working properly, they've not been commissioned to have fast enough ventilation rates, or they're not correctly operated to meet those building standards. So then how does actually CO2 tie into air quality and ventilation? Well, normally we as humans exhale with every breath a CO2 concentration of about 40,000 parts per million, or ppm. And in indoor spaces, particularly with insufficient ventilation, it can only take a few minutes for that CO2 concentration to add up to beyond 1,500 ppm. And just for context, the normal outdoor CO2 concentration values are between 400 and 430 ppm, and these are considered the ideal ambient conditions for humans to live in. Studies have shown that at the same time as indoor CO2 concentration rises, the perception of stuffy or stale air also increases. And what can stale or stuffy air mean? At minimum, discomfort, because no one likes to sit in stale air. But it can also mean a higher risk of exposure to harmful gases, formaldehyde, volatile organic compounds, and particulate matter, all of which can have a detrimental impact on your health. Even CO2 concentration in large amounts can lead to headaches or fatigue or even health issues. Therefore, measuring CO2 as a gas indoors is a great way to measure the indoor air freshness and whether the ventilation levels are sufficient in that space.
That's really interesting, Caitlin. So, walk me through exactly what we will be covering today.
I'd like to first show how ventilation, as measured by CO2 concentration, impacts our sleep and cognitive performance. Then I'll dive into Sensirion's latest CO2 sensor, the STCC4, and why it's a game changer for enabling mainstream CO2 sensing. Finally, I'm going to highlight the benefits of the minimum indoor air quality parameters, which are CO2, temperature, and humidity, and how indoor environments can be monitored through a number of applications.
Caitlin, indoor air quality has a direct impact on our physical health, right?
Yes, it does. And discussed before, CO2 concentration is a great proxy for monitoring air quality in indoor environments. I'm going to go into two topics, sleep quality and cognitive performance, where studies have shown the impact of poor indoor air quality. First, let's dive into sleep quality. Poor sleep has a wide range of effects, ranging from short-term poor general health and performance to long-term issues such as health disease and metabolic disorders. Given that we spend about a third of our lives sleeping, it makes sense to maximize the chance of great quality sleep. How is sleep quality impacted by poor ventilation, and where does measuring CO2 help in assessing the air quality? Studies have shown that CO2 concentration can quickly increase in bedrooms, even potentially reaching above 1,000 ppm within an hour if there's no active ventilation. In fact, 1,000 ppm is the generally recommended CO2 concentration limit before indoor conditions can impact comfort and performance. For instance, one study found that 20% of people can start feeling symptoms of fatigue at CO2 concentrations above 1,000 ppm. This may be due to the body reacting to the higher CO2 concentration or potential increase in cortisol levels. But the minimum is that you're in an environment with stale air, leading to discomfort and potential exposure to the harmful contaminants that we discussed before.
Wow. So, Kaitlin, all of those issues could be helped with smarter ventilation, right?
Yes, better ventilation in bedrooms can significantly reduce the CO2 concentration there and therefore maintain better air freshness overnight. This graph really helps to demonstrate that. Over 8 hours of sleep time, the change in theoretical CO2 concentration is significantly impacted by different ventilation rates. To give some context on those ventilation rates, the Federation of European Heating, Ventilation, and Air Conditioning Associations found that ventilation rates between 7 to 10 liters per second were required to keep CO2 levels below that 1,000 ppm level. Otherwise, it can be possible to reach CO2 concentrations as large as 4,000 ppm within a few hours. Why do CO2 concentrations even reach such high levels? This is thanks in part to more energy efficient buildings with better airtight windows. And while this helps to reduce the energy needed for heating and cooling, it does mean that the air exchange between indoor and outdoor is significantly reduced. And this helps to contain CO2 and other harmful contaminants unless it's mechanically ventilated. Coming back to the impact of poor air as measured by CO2 concentrations above 1,000 ppm and sleep quality, studies have revealed several outcomes. There's a higher chance of waking up during the night. It can take longer to fall asleep, also known as your sleep onset latency or SOL. You can have 50% more movement while you're sleeping and 25% less deep sleep, which means much less restorative sleep. There's more than 20 papers that are correlating sleep quality with ventilation, and all of them use CO2 concentration as the proxy to measure the air freshness. So what's the conclusion? CO2 sensors are effective at measuring air quality of bedrooms. It can help to provide feedback to improve sleeping conditions.
So, Kaitlin, you mentioned earlier that CO2 exposure can also affect our cognitive performance as well. So, talk to me more about that.
Well, it's clear that poor sleep can lead to reduced performance during the day. Sometimes caffeine just doesn't cut it. But to make matters worse, your air quality while you work can also impact your cognitive performance. Studies have shown that student and employee absences significantly increase when learning or working in environments with higher CO2 concentrations. One reason can be the increased risk of exposure to viral loads from breathing in exhaled air from others around you. Additionally, exposure to higher CO2 concentrations for a period of time can lead to reduced cognitive functioning. This could be due to the body chemically reacting to the higher CO2 concentration and affecting the brain function, in particular through a change in the intake of O2 in your brain fluid. However, the exact mechanisms between environmental CO2 concentration and PCO2, which is the partial pressure of carbon dioxide in blood, are still not fully understood. At minimum, the environmental conditions associated with high CO2 concentrations lead to a significant decrease in cognitive performance. One study showed that already at 1,000 ppm, performance in 6 of 9 different cognitive tasks decrease, with even more pronounced results at 2,500 ppm. In general, the higher the CO2 concentration or the exposure time, the more likely that the cognitive performance will decrease. And as we discussed before, environments with high CO2 concentrations likely lead to employee discomfort and risk of exposure to viral loads. So there's a lot of reasons to make sure that the ventilation rates are high enough to enable fresh air working conditions. In the end, students, employees, employers, and even building managers all benefit from monitoring indoor air quality, and CO2 sensors are a way to enable healthy and optimal working conditions and learning conditions.
Absolutely. Now, it seems that sensors are the key to enabling sleep quality and cognitive performance. So, what can Sensirion offer to support these topics?
Today, every cent counts when creating a competitive product. Sensirion focuses on designing the right products for the right applications and are experts in miniaturizing sensing technologies while maintaining performance, reliability, and ease of integration. Miniaturized environmental sensors can be integrated into a variety of applications with the right price-performance ratio and help to enable product differentiation. We design and produce miniaturized environmental sensors for measuring temperature, humidity, volatile organic compounds, NOx, and particulate matter. Sensirion also has worked on miniaturizing CO2 sensors to bring CO2 monitoring to the mass market through their expertise in gas sensing technologies. The portfolio, now including the new STCC4, includes 3 sensors with 3 different technologies, all with their own advantages for different markets and applications.
So, Kaitlin, talk to me about the different principles involved in CO2 measurement.
There are 3 different technologies that you can use to measure CO2. The first and the most well-known on the market is NDIR, or dual channel non-dispersive infrared spectroscopy. And Sensirion's sensor using this technology is the SED30. These NDIR sensors are highly selective and reliable, but the miniaturization is limited by the signal-to-noise ratio that you can achieve. The SED4X uses a photoacoustic NDIR approach to break through the size barrier while maintaining the high accuracy and selectivity to CO2, and it's able to reach an order of magnitude smaller footprint. However, it's still much larger and higher power than chip-based sensors such as Sensirion's SHT4X. This is why Sensirion has now launched the STCC4, which is an ultra-compact and low-power CO2 sensor using thermal conductivity as the measurement principle, in combination with Sensirion's CMOS Sense platform.
So, how can the STCC4 help me here?
STCC4's value proposition is striking the right balance between performance, size, power consumption, and price. It's been designed with mass market CO2 sensing in mind, and it's easy to see its most striking feature, the size. One of the smallest CO2 sensors on the market, STCC4 has a low average current consumption and an optimized accuracy for indoor air quality applications, as well as a striking cost efficiency to traditional NDIR and photoacoustic NDIR sensors.
So, Kaitlin, what kind of features are we talking about with the STCC4?
STCC4 has been engineered and manufactured in Switzerland in a company deeply rooted in innovation. The sensor comes with multiple operation modes to enable easy setup and optimize low power sensing. The sensor also has a simple SMD assembly and taper mill packaging, so it's easy to integrate it into high volume applications. The sensor communication is also very uncomplicated using the I2C interface, and it's also straightforward to compensate for temperature and humidity, also known as RHT, in the local environment through a dedicated I2C controller interface. Why is RHT compensation needed? Compared to optical sensors, which include a discrete RHT sensor in their packaging, STCC4 has been focused on minimizing its footprint as much as possible, and therefore takes the advantage of collecting the information from an external sensor. 2 compact sensors for measuring indoor air quality are a great bundle, and they also offer the highest design and flexibility. In principle, temperature, humidity, and CO2 can be considered as the minimum parameters for ensuring indoor comfort conditions, and each have their own optimized range. Indoor air temperatures are recommended between 20 to 25 degrees Celsius to minimize release of VOCs and reduce the risk of heat-related illnesses and weakened immune system. For relative humidity, this should remain between 40 to 60% RH to minimize the conditions for mold or mildew growth and the chance of someone becoming more susceptible to viral-related illnesses. And as we discussed earlier, CO2 concentration should remain at least below 1500 ppm to ensure that there's sufficient air freshness, health, and comfort.
What kind of specific applications would these solutions be a good fit for?
Indoor air quality can be monitored in a number of applications. For instance, by integrating SHT4X and STCC4 in small air quality monitors and smart home devices. Ideally, these devices provide some sort of visual or oral feedback to the users on the indoor conditions, such as a traffic light indicator. These monitors could also be connected to a smart home or building management system to enable an automatic ventilation control. In a similar way, thermostats or room control devices overall could incorporate the SHT4X or STCC4 to directly monitor indoor conditions versus the desired settings in different rooms, thereby optimizing the ventilation and heating. Appliances like air purifiers or air conditioners can also use SHT4X and STCC4 to optimize their energy efficiency by maximizing its operation when people are most benefiting from it.
So, Kaitlin, what would you like my audience to take away from today's Chalk Talk?
One is that indoor air quality has an impact on health and performance, and CO2 is a proven metric to quantify that air quality. Two is that STCC4 is a groundbreaker in the CO2 sensor market and is particularly optimized to bring CO2 monitoring into everyone's hands. And three, the combination of CO2, temperature, and humidity parameters are the minimum for monitoring indoor air quality at home, office, or in public spaces through monitors, building control, or appliances.
Fantastic. Well, Kaitlin, I think that's all I have time for today. Thank you so much for joining me.
Thank you for having me.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Sensirion. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.